And then the MAC address still have different types. In our network, there's different type of traffic, different type of frame. Okay, of course, the most widely used is the unicast frame. Unicast frame. What means the unicast? Unicast means when the computer sending the frame out, then the destination is only one computer, is only one host. And all the other hosts will not accept this. Okay, that's the one sender, one receive. Okay, one sender and one receiver. Okay, and then in here, in this frame, the destination MAC address, just the MAC address of the host B's NIC, okay, network interface card. And how to identify this? There's a specification said the unicast MAC address, the eighth bit should be 0. Should be 0. Okay, that means the first number, for example, 4A. Okay, there's 8. Okay, there's 48 bit long. So, okay, this is the OUI, and also there's also other 3 segments. Okay, this is the MAC address. Then in the first segment, this should be an even number. Okay, should be an even number. That means this is 0. Okay, this is a unicast frame. Okay, unicast frame. And another often used frame is the broadcast frame. The broadcast frame means one sender and all the other computers in the network should receive. All receive. Okay, when this is broadcast, then in the frame header, okay, there's a destination MAC, there's source MAC, and there's type. Then the destination MAC, of course, the source MAC still should be the host A who sends the frame, then use whose MAC address. And then destination MAC should not use other one host's MAC address. Okay, then the MAC address should be use a special MAC address. That's the O1s. FF means O1s. Okay, F means 1111, and another F is 1111, and then 48 bits are O1s. When this destination MAC address is the F, then this frame sending out by host A should be received by all the computers in this network, and then they will receive it and then process it. Okay, this is a broadcast, and then there are still another type, 3 types. Okay, unicast, broadcast, and then the last one, the multicast. Okay, the multicast. Multicast means the computer host A sending out a multicast, then a group of computers, not all, also not one. Okay, only a group of computers should receive this frame. Of course, there are some computers not receive. Okay, but not only one. Okay, there are a group of computers. And in this scenario, the destination MAC address of Ethernet should be a multicast MAC address. Okay, in the destination. Of course, in the source, in this frame, there's a destination MAC and there's source MAC, and then the source MAC still who send, host A send, should be the host A's MAC address, and the destination MAC address should be a multicast hub MAC address. The multicast MAC address is defined as the eighth bit should be 1. Yeah, this is the opposite. This is the opposite of the unicast frame. Okay, the unicast said the eighth bit should be 0. We can see the eighth bit should be 0. This is unicast frame. And the multicast said the eighth bit should be 1. Okay, this is multicast. And we can see the broadcast is all bit, all 48 bits should be 1s. So broadcast is a special value is included in the multicast MAC address. Okay? Yeah, right. Okay. Then this is the multicast MAC address. Okay. And then now we have the Ethernet frame format, and we know how to fill in each field. Okay, the destination MAC, the source MAC, and the type. Okay, we know what the value should be put into this field, and then the data should sending out. Okay, then the data sending from one computer to another computer. Then Ethernet originally, the most early Ethernet is a coaxial cable, and then all the computers are connected to this coaxial cable. That means when one computer sending out the Ethernet frame, all the others will receive it. Then all the others receive it. Then decide who should accept by the destination MAC. Okay. Then there is a problem. If the two computers sending out the data at the same time, then what happened? Okay, this is a collision. Okay, collision, and then these two computers' signals will be interfered. Okay, that means the data will be destroyed, and the receiver, any other computers, cannot listen clearly of each one's signals. Okay, so the collision should be avoided. Okay, should be avoided in the network. So how to avoid? We use the Ethernet use a mechanism we called CSMA and then CD. What means? The MA means multi-access. That means the network media is accessed by many computers, many hosts. Many devices will use the same media. Okay, this multi-access. Then carrier sense. Carrier sense is a mechanism that says when computer C wants to sending out, when the computer C wants to sending out the data to this media, okay, first should listen to the media. If there's any other device is sending, if any other device is sending, then the computer C will hold. That means not send out the data. Until what? Until the computer B is finished. Then the media is idle. Then the computer C can send out the data. Yeah, this is to avoid the collision. Okay, that's a carrier sense. Carrier, that just means the signals in the network media. Then sense means to detect. Okay, detect. And then if these mechanisms, I think these mechanisms can avoid the many collisions in this network, but not all. That means there's some scenario that when this media is idle, then the two computers want to send data at the same time. Because the media is idle, then the two computers sending at the same time. Then when the sending out of course, these two signals will collide, okay, will collide. Then the data will destroy. So the carrier sense is not the only mechanism. We also need another mechanism we call collision detect. That means when the media is idle, then the device can send out the signals, but at the same time, this device should detect if there is a collision or not. If there is a collision is happened, then the device should stop sending, and then make the other device know the collision is happened, and then the both device will hold back, and then waiting a random time, and then begin to sending again. Of course, carrier sense there if it's idle, then begin to sending again. Okay, this is the mechanism we called CSMA CD. Okay, this is the mechanism how the device to use a shared media, Okay, and then the frame processing. That means now the host A, we got the format of the frame, okay? Know each field, how to fill to each field, okay? And then the data, how to send, how to use the media. Then the device, of course, in this network, maybe there are many devices. Then the device will receive it, okay? Will sense, will get the signals in the network. And then this is the signals. Okay, when the device first receives it, then first we'll use the FCS, frame checksum, to detect if the signals have been destroyed or if it's not correct when sending from source to the destination, if there is some destroyed. And then if it's okay, then to decide if the destination of this Ethernet it's itself or not. That means should use the destination MAC in the Ether frame to compare the destination MAC with the MAC address bound in the NIC of itself. If it's the same, that means this frame is the destination is host B. If it's not the same, then this frame will be dropped. If it's the same, then the frame header and the frame trailer will be stripped. And then the data, of course, it's the IP packet. Then we are forwarding to the layer 3. Yeah, forwarding to layer 3. In the layer 3 protocol stack to process this IP packet. Okay, this is how frame is processing by the host. Okay, and then we go to the end of this chapter. Okay, in the summary, there are two questions. First, how does the Ethernet determine the protocol to which a processed frame should be delivered? That means Ethernet is on layer 2, okay, and the layer 2. And the Ethernet can carry many protocols, such as the IP protocols, and for the Novell, the IPX also can carry it on Ethernet. Also, there's IBM's SNA package and other protocols and so on. Then, if the packet go to the destination, then how do the host knows which protocol should process this data? Okay. Use what? Use the field in the Ether frame. Which field? The destination MAC address and the source MAC address, and then there's a type field. Okay. The type field will tell the computer what is carried, what the upper layer is carried in this frame. Okay. This use the type field of the Ether frame. Okay. Then the second question: how is it determined Whether a frame should be processed or discarded upon being received by the end device. Use what? Use the destination MAC address, okay? In the frame, there is a destination MAC address, and then the computer receiving this frame, this computer, there is a NIC card, there is a network interface card, okay? Network interface card. That network interface card itself have a built-in MAC address, okay? Built-in MAC address, okay? Then we'll compare the destination MAC address and the MAC address built-in by this NIC. If it's the same, then means the destination of this frame is this computer, and then will be accepted. And if not the same, then will dropped. Okay, this is the answer of these two questions. Okay, then we go to the end of this chapter. Thanks to listen to my presentation. Goodbye.